Hey, for this video I invited a Microsoft cybersecurity researcher to talk about some of his amazing research that he publishes online, publicly, on his own blog posts. He's an amazing author. He's written a visual threat research book recently. He released a few months ago, and it's an amazing read if you are looking for threat intelligence and looking to see visual representations of it. He's also a public speaker into SANS events. Everything you want to know about him will be in the description. If you want to follow him on his social medias, if you want to consume his content, I highly recommend it. So he's an amazing writer, cybersecurity researcher, but also an amazing person to accept such an invite from me. I really appreciate Thomas's willingness to join me in this conversation. So without further ado, let's get into the talk. Hey everyone, thanks so much for joining. In this conversation, I reached out to a security researcher at Microsoft. He's an amazing person because he's got books published, he presents at conferences, and he's part of a leading team at Microsoft that helps with a lot of very cool stuff that I'm not sure I can say. So, hey, Thomas, can you introduce us a little bit about yourself? Tell us a bit about what you do and what are you here for?
Sure. Thank you, Andre, for the invitation. So my name is Thomas Roccia. So I'm currently working at Microsoft as a Senior Security Researcher. So my work is mainly to research malware and novel techniques and improve the Microsoft product. And I'm also doing some investigation and understanding like how the threat landscape is working, so for some specific threats as well. So this year I've been a bit changing for me as well, because I've been involved in LLMs and artificial intelligence works related to cybersecurity and mainly threat intelligence and malware analysis. So yeah, it's mainly me. So I've been publishing my book Visual Threat Intelligence last year. And yeah, I used to publish some of my research on my blog, on Twitter as well. And I'm a big fan of, the visualization and understanding like concepts in a simple way.
Yeah, I had a look at your book. I read some of it, and of course you present very important topics from cybersecurity with visual graphics, and it's amazing. If you haven't read or seen anything around those lines, make sure you have a look at that. But then recently you made a blog post about LLMs and threat intelligence, and I thought it was an amazing read up. So you're proposing and you're sharing through your blog tools that help the security engineers and also the field work with joining these two capabilities in a very unique way. Can you share us a little bit about what that looks like?
Sure. So to give you a little bit more details, so recently I've been working a lot with LLMs and how it can be applied for cybersecurity and mainly threat intelligence. I just came back from Washington, D.C., where we presented some of our research with my friend Roberto Rodriguez. So I'm not going to redo the presentation because it was recorded and it will be published soon, but I will give you some details about the work I'm doing around that and some of the tools that have been published. So let me share my screen. Perfect. So this is the blog I published 4 months ago, or November, 3 months ago. So the goal of this blog post was actually to present a little bit more the application of LLMs, large language models, to threat intelligence. So basically, how we can use that technology for threat intelligence for solving some of the challenges. And it was also exactly the topic of our presentation last week. So this blog is a bit technical and a bit more it's an overview, and I didn't want to explain what is already public on LLMs and all that stuff. So I really focus on threat intelligence, and I wrote some piece of code because I wanted something really practical for the reader as well. So let me go through the blog post. So first, I'm going to talk about, I talk in this blog post about the threat intelligence challenges. So there is multiple threat intelligence challenges, especially, for example, there is a lot of data that are available, and sometimes it can be, time consuming to deal with all that information. It can be also a bit overwhelming because there is every day there is a new threat reports, new data to process, new indicator of compromise. Also, there is a versatility about different kind of tools and all that stuff. And sometimes it can be a bit difficult for new analysts, to understand the different concepts and use some tools, understanding the threat landscape and all that stuff. And of course, there is also the threats are constantly evolving and getting more and more complex over the days. So just to give you a brief overview about some of the challenges I'm trying to solve through that blog, but basically that's it. So first, I'm discussing about what is prompt engineering. So to make it simple, to keep it simple, prompt engineering is basically a way to interact with a large language model with crafting a prompt. A prompt is basically a sentence where you will ask something. And and prompt engineering is very important because the more precise you will be, the better the result will be as well. So it's very important to understand this concept to be sure that you are able to ask clearly what you want to a large language model. Through the blog, I'm discussing some of the the ideal elements that make a good prompt, such as, for example, clarity.
Mm-hmm.
Clarity is very important. Define the task that you want the model to perform clearly. So this is very important because it's not a human, it's a machine, and the machine is working with a large database of information. So the more clarity you provide, the better the result will be. And you can directly also make the models find the right information for you without getting all the information. Specificity, so that's pretty much in conjunction with clarity. So to explain a little bit more, think about an LLMs. When you ask something, an LLMs will have like a 3D representation of the information that are available. And when you ask something, the LLM will basically define an area of this representation and find the information that you want through that 3D area representation. So that's really important to be specific, because automatically the LLM will be able to find the right place in the 3D representation, which will be more accurate in terms of the result you can get. I'm not sure if it's clear.
Yeah.
I try to explain a little bit more simple, but basically clarity, specificity, and iteration.
Would you say that giving examples is a good way to specify what you want as well?
For example, you can give an example. You can also define a role. Like if you say act as a threat analyst, you reduce the window of the information, and the model will be more accurate because it will directly go through that specific area of the database to retrieve the information. Does that make sense?
Absolutely, yeah.
Also, I'm discussing about some of the common pitfalls, such as, for example, over complexity. Sometimes we are making too much details and it doesn't work completely great. Ambiguity as well. It's some of the, like if you ask something without precisions and without specific information, then the prompt will be too broad. Exactly. No example, as you said. Sometimes it's also very interesting to provide a good example because it will help to understand the output that we need. And I think also these two ones are very important. Misplaced belief in models understanding. So this one is very important because the LLMs that we are using today are so powerful that sometimes some people forget that they are talking to a machine, and they assume that the model will directly understand the information they are sending to the model. So that's very important because this is not the case. This is a machine, and sometimes the information is not completely accurate. And also, it could have also sometimes some what we call hallucination. So when you ask something, the model will hallucinate because it doesn't have the information that he tried to provide you the data. So you need to be, prompt engineering and LLMs are super powerful, but we still need to be critical in front of the result we can get from this kind of technology. And also ignoring obsolescence. The models that we are using today have been trained until a certain date, meaning after that date, the information that we try to retrieve are not available. So today there is some stuff that can bypass this specific pitfall, such as, for example, using RAG, retrieve augmented generation. I'm going to talk a little bit more about that later. And the ability to automatically browse internet when we ask something. So that's a simple representation about an anatomy of an ideal prompt. In that case, you can define like the role definition, define a clear objective, precision and specificity, close-ended question, and iterative refinement. So that's a basic example. Okay, let's talk about some of the practical elements that I share in this vlog. First of all, few-shot prompting. So this one is very interesting. You can actually, few-shot prompting is a way to actually providing example to the output that you are expecting. So here, what I'm doing is creating actually some example that I'm expecting. So in that case, I'm providing a blog post, and I want the model to create a mind map based on this blog post. So what I'm doing here, in that case here, I'm defining the system. So you are an assistant that will help me craft a mind map and so on and so on. And then I provide an example about the content that I want the model to, summarizing and create the mind map. And here it's a threat report. And then I provide information about what I'm expecting. And in that case, this is the mind map code. And finally, we can iterate like that. And which is really interesting here is the more example you provide, the better the result will be. So let me show you how it works. So I published the code on my GitHub, and you can find the code directly available, and you can reuse by yourself. So this is the code with, as you can see, the definition of the system, the role of the LLMs, the user content, and the expected output. And then when you send the blog directly to the code, you have first a summarization, and then you have the mind map flowchart, that code that has been generated, which looks like this. And then automatically you have a blog summarized in a mind map with the key findings, some interesting information. So you don't need to spend more time reading the blogs and go through it directly. You can directly pass through your routines, through your code, and extract the most relevant information. And this is just a basic concept, but imagine that you can do that for extracting indicator of compromise. You can also use it to extract like MITRE techniques ID and more and more. So this is very powerful.
Yeah, absolutely.
Another example. Retrieval augmented generation. So we've been discussing about that last week during the SANS CTI summit. Retrieval augmented generation is a very interesting concept. So remember, I talked about the obsolescence of a model, meaning the model has been trained until a certain date. It has not been trained also on your private data, on your personal information. So retrieval augmented generation will actually solve that. You can basically add your own data and add some specific information to the model, and it will be used as an additional database to retrieve information related to the context of the RAG you provided. So how does it work basically? So first of all, you need to prepare your data. So imagine you have like it could be PDF files, it could be Markdown, it could be RST file, it could be anything. So in that case, what we do here, we use the MITRE attack groups as a data source. Then you need to tokenize. The concept principle of tokenization is basically to reduce the token limitation and to understand the cost of the request and all that stuff. It's basically for optimization. Then you split in smaller chunks that will be easier to retrieve the information that you want. And then you put all that information in what we call embeddings or a vector database, which is basically what I said, a 3D or multi-dimension representation of the data. And then your model is ready for input. So what I did here, I reuse the proof of concept created by Roberto. So there is the walkthrough directly, but basically, which is interesting is this piece of code. So after you prepare all the data and everything, you can directly request or ask information to the LLM. So how does it work exactly? Here, I'm asking who is Lazarus. So what is going on the background? The model will get that information and it will search through the database we provided and prepared before through the RAG setup and all that stuff, and automatically retrieve based on the similarity from the question and the result, retrieve the most relevant information. It retrieves that information from our RAG and create the answer that we are expecting. And in that case, as you can see here, getting relevant document for query, and Lazarus Group is a North Korean state-sponsored cyber threat group that has been attributed to the Reconnaissance General Bureau. That's it. So we get all this information. So this is very powerful because you can basically give any kind of information to a RAG. Could be even your personal data, the data of your company, and you can build your information directly like that. So what I did here on top of that, I added the memory to keep in track the previous interaction that you have. So here is the same example with the memory. I'm talking about it because technically adding the memory is a bit challenging. It's not like super easy to do. So that's why I put it in the blog. So again, there is the whole code. There is everything that are available on my GitHub, and everyone can reuse it for free. So here I'm asking who is Lazarus. So we have the answer. Lazarus is a North Korean state-sponsored group, and so on and so on. And then the second question is list all the techniques used by this group. And as you can see, I do not specify that I'm talking about the Lazarus group because we just discussed about it before. So the model is retrieving the context and have some memory. And here we have the information formulated by the model. The Lazarus group use variety of techniques in their cyber operation. Some of these include social engineering, spear phishing, and so on and so on. That's it for the RAG. So the RAG is very interesting because you can basically improve a model with your own data. Again,
without RAG, if you ask who Lazarus is, it would probably look for anyone named Lazarus, right?
Exactly.
But now you're grounding it within the constraints of threat intelligence that names Lazarus against this particular threat actor. Right?
So in that case, the model already know who is Lazarus because there is plenty of resources online talking about the Lazarus group, and the model have been trained on that. But it's basically an example to show that we can train of the matrix, the attack groups, the information that we have directly to a large language model. So I believe that if you ask who is Lazarus without the RAG, it will be able to retrieve information, potentially not as detailed as we want, like such as the different techniques that have been used because it's part of the matrix attack. But imagine if you have information that are not public, you can basically create your RAG on your own data. So the code is here on my website as well, RAG attack, so you can reuse everything. There is the setup, the attack chatter with memory, and the example we just discussed.
Awesome. So these are all Jupyter notebooks that we can run.
Yes. So the last one that I want to discuss, which is super powerful, is the React framework and agents. So to make it simple, let's explain first about what is the React framework. So the React framework is acting in three different pieces. First, there is SAUT, which is the thinking of the LLM after you send the request, the question. Based on that SAUT, they will have action. The action here is basically a tool or a capability that you can incorporate to your agent for, generating information and finally formulating the observation. And this is a loop. So an agent is basically a way to automatically interact with information and element that you are providing. So how does it work in practice? So what I did here, I created a basic example with the Mystic Pi library. So for those who don't know, Mystic Pi is an open source Python library dedicated to threat intelligence investigation. So it's basically used to, for example, request a threat intelligence provider, enrich information, create graph, make your investigation, and so on. So this is the Swiss Army knife of threat intelligence. So what I did here, I created a small class where I created three different functions. First one is IP information that will retrieve threat intelligence about an IP address. Second one will be communicating samples. So it will basically retrieve information about samples that are communicating to a specific IP or specific domain. And the last one is retrieve sample information, sample identification, that will basically retrieve information about specific sample. And here we have our tools. So remember, in the React framework, I was discussing about thought, action, observation. The actions are our tools. So you can define the different tools based on functions, but a tool can be anything. It can be a RAG, it can be an LLM itself, it can be a function, it can be a request to an external API, it can pretty much be anything. So here we have three different tools. We have the retrieve IP information, which is our function here, the retrieve communicating sample, same here, and the retrieve sample information. So which is very interesting here is that there is three different parts to define a tool. The first is the name, the second is the function, which is the function we created before. And the last one is the description. And the description is very important because it's a prompt. And this prompt will be used by the LLM to understand what kind of tool it needs to call and how to call it and how to retrieve the information. So this is super powerful. So for example, here, if we take this example, the description of the tool retrieve IP information is useful when you need to look up threat intelligence information for an IP address. So with that in mind, we have our agent with three different tools, and automatically it will be able to retrieve the information that we want based on what we ask. So this is an example here. I'm initializing the agent. Something which is very important here is the zero-shot React description, React. So I'm using the React framework as we discussed. And then I'm running the agent with these specific questions. Can you give me more details about this specific IP address? Then I'm asking how many samples are related to this IP? And if you found samples related, can you give me more information about the first one? And then how does it work? First, you retrieve the information about the IP address. The IP is associated with ASN, located in Netherlands, owned by Hosting Technology. There are 5 samples related to this IP. Second question. And the first sample has the SHA-256 that we can see here. And it's a Win32 exe file and has been tagged as malicious by several antivirus engines, and it was first submitted for analysis and so on and so on. So automatically, we do not need to think about the algorithm or the way to interact with multiple functions. The LLMs will, by definition, the agent will, by definition, find itself the right function to call and summarize the result. So we are basically automating the threat intelligence process and investigation. You are solving like the difficulty to interact with multiple tools, and it's super easy to use. So here is basically how does it work in the background. So when you ask the questions, you can see. Unfortunately, I can put in stop because it's a GIF. But basically, that's fine. Basically, you can see that it's retrieving the result. When then we have the thought, then we have the observation. And finally, we have the answer. So just to explain a little bit more, when we ask the questions, the agent will understand which tool it has to call to answer the specific question, find the right tool, run the tool. So the observation will be basically the result from the tool, where we have, in that case, it will be pulled out from Mystic Pi, but it's actually requesting VirusTotal. So we get the information from the IP address or the sample and so on. And based on this output, it will produce the answer that the analyst is expecting. And then we have the final answer here. It's basically summarizing the different actions. So this is super powerful. Here, it's a basic example, but as you can imagine, you can do pretty much what you want with it.
Yeah, it seems very flexible as well, right? Because you can create the actions, right? You can essentially create whatever actions you want.
Exactly. You can create the actions. You can even make more complicated stuff. For example, you can also create an agent that will automatically create code on the fly to execute a specific task. So imagine you don't even need to know how to code. You can create an agent that will automatically generate the code based on the expecting output. So it's not currently perfect sometimes, but it works pretty much very well.
That's awesome.
So yeah, that's it for this specific blog.
Yeah, it's incredible research. Thanks so much for putting it out there, and sharing all the great notebooks that you mentioned.
Thank you very much.
Yeah,
thank you. And the SANS CTI Summit presentation that we did last week is have more information as well. So Yeah, and more material as well. So I really recommend to have a look when it will be published.
Okay, so this is not everything that we talked about. There's actually more, and this will be coming in the future video, okay? So hopefully you stick around, make sure you leave a like, comment, and subscribe if you think this is useful for you. Thank you, and see you next time.